Hey there everyone, welcome back to another live. Today we'll be looking at polymers, IGCSE Chemistry. Let's get started. So let's start with defining polymers. Polymers are molecules, large molecules built by linking smaller molecules smaller molecules called monomers. Let's change the color and write it monomers. So now note that in polymers, right, all the bonds that you're going to look at are all covalent bonds. Okay. Now, if you don't know what covalent bonds are, please go study that and come because it's very important to know what kind of bonding and linkage and everything is going to be there. So let's start out with this. Okay. Let's say we have these. Okay. These are our monomers. Now, what are our polymers? When we link these smaller molecules into bigger molecules, so this becomes a polymer, right? Um, then before we continue, let's keep this aside that there's a difference. I'll put it like this. There's a difference between bonds and linkage. Okay, they are two different things, and we'll look at them as we go ahead in this. So let me um so there are difference between bonds and linkage. Okay, now there are two types of polymers. Okay, so we have polymers. They are of two types. The first one is addition, and the second one is condensation. Condensation. Let's look at each of them as we look ahead. So let's look at the first one, addition, polymerization. Okay, I will just write addition here. Now, when you're asked to define addition polymerization, right, it is a type of polymerization which only occurs in C double bonds. Okay, double bonds. So uh these double bonds are in the monomers. Okay, but when a polymer is formed, the polymer will contain single bonds. Now, this may sound confusing, but as we look at an example right now, we will understand what I'm trying to say. So, polymer will contain single bonds. So in addition, basically addition reaction, this means that it can only happen in alkene monomers, right? So once you have, let's take ethene for example. Okay, ethene is an alkene, right? This is how ethene looks like with its double bond here, right? So this is called ethene. Now this ethene is our monomer, but if we were to write or draw its polymer, now when you're in addition polymerization, when you're writing down its polymer, you add the name poly in the beginning. You add the prefix poly, which means many. Okay, so the polymer for this ethene will be polyethene. If I had butene, then it will be polybutene. Now if I want to draw this, then this is how I will draw it. Okay, C. Now you can see that I've drawn a single bond over here, not double bond. And now because there are many monomers being joined, I'll link them. Okay, so H. And then this will continue on forever as much as we want. Okay. Now this is not how I end it. How I will draw it is that I will draw a line like this, a line like this and draw it into brackets and write N over here. Okay. Uh, yes. Now we also need to identify something called repeating unit. Okay. Repeating unit. Now, repeating unit is identified by trying to find a pattern which repeats. Okay. So, for example, let's say I have another polymer. Okay, I have a polymer this time. Let's say it's CCHHCH3. Let's just leave it H here. Uh, CH3 H, then CH3 just a second, HH. So now we know that this is a polymer. Okay. Now, how do I find out the monomer from this? You find out the monomer by trying to identify the repeating unit. Now, from over here, you can see that this repeats. Okay. So you have an H here, CH3, H here. It repeats over here. H8CH3H. Then it again repeats over here. So you can know that the repeating unit, so that becomes a repeating unit, doesn't it? So a repeating unit becomes C, H3H, and H. Now you see, I've made a mistake here. Pause the video and try and see where the mistake has been made. Okay, so where the mistake has actually been made is that I have drawn single bond here. When I'm writing down the repeating unit, it will always be a double bond because this is the monomer that I'm using. So monomer that I'm using, right? So once this monomer is then repeated, then I'll form the polymer. So that is why this will have a double bond over here. And let me see if there's anything else we need to know for addition polymerization. We are done with repeating unit. We are done. So the prefix poly here, the prefix poly means many. Okay, so many monomers coming together to form a polymer. Then happens in CC bond. So this N over here, it's used to represent or indicate a large number of repeating units. So indicate a large number of repeating units. And that is all we need to know for addition polymerization. Let's move on to condensation polymerization. Okay, so just a second. So let's write down condensation polymerization. Okay, so now in order to define condensation polymerization, you have to say that it is formed when two monomers, watch it, two monomers, are linked with the removal of a small molecule, and you end it here. And this small molecule is usually water. And we'll look at how. Okay, so let's look at the first type of condensation polymer. Let's look at nylon. Now, nylon here, this is a polyamide. Okay, now what does this mean? This means that it's a polymer with the amide linkage. Okay, amide linkage. Now, this is what the amide linkage looks like. So, C in this is the amide linkage. So, any polymer that has the amide linkage is a polyamide. So, nylon here is that type of a polyamide. Now, how do I draw nylon? Okay, nylon is formed by the joining of two monomers. It's joined by the like it's formed using the joining of a dicarboxylic acid and a diamine. So dicarboxylic acid and a diamine. Okay. Now don't get confused. Di basically means two, right? So you have two carboxylic acid and two diamine. So how will I draw the dicarboxylic acid as the monomer? So yeah. So now this is how I will draw the carboxylic acid. So I have a box here. Okay. Okay, I'm going to shade this box. Now I will draw a carboxylic acid, a COOH on this side. And I will draw another COOH this side. Now you'll notice that there's one carboxylic acid, there's another carboxylic acid group. That's why it's called dicarboxylic. Now, so I've drawn this one. Now I have to draw diamine. So now amine is basically NH3, I think. But or in wait, sorry, NH2. So let's say that I have this box here. I'm not going to shade it, okay? So then I'll connect this to N, H, and H. So N, H, and H. Now, when we are linking them, okay, we said that there's a small molecule formed called water. When we are linking them, hydrogen from here and OH from here will come together. So H plus O, so basically H plus OH minus, and this will form water. Now, this water is a small molecule that we're talking about being formed. Small molecule. So now if this water is removed and you're joining these two, how will it look like? It will look like this. So I have my box here, my COO. Now wait, we'll come back here. So I have COO. Now this is removed and this is removed, so I'll connect it to N, H, then here, N, H, now here. Now this is only one unit, right? But if because it's a monomer, I'll continue this. So over here, I'll then join it to this one. So this is how it will turn out to be. And I'll leave it here with the N. And then I'll connect it to, oops, no. I'll maybe add N. Yeah, N, H, and then I'll leave it N over here. So now if you were to find the repeating unit from here, the repeating unit will actually be this. It will be from here all the way to here. And this, as we said that this is the amide linkage, right? You can see the amide linkage being formed over here. Wait, just a second. Yeah, so this is the amide linkage that we're talking about. So we have another amide linkage here and another amide linkage over here. So now if they ask you a question, how many molecules of water were formed? You have to say 3. Why? Because I see 1, I see 2, I see 3. So the number of molecules, water molecules formed will be the same number of amide linkage you see that have formed over here. Is there anything? So yes, this one is called nylon. Okay, nylon. It's formed with a carboxylic acid and a diamine. Let's move on to the second one, forming PET. Let me just, yeah. Now PET stands for polyethylene terephthalate. Okay, let me write it down. Polyethylene terephthalate. Okay, now this is a polyester. Okay, a polyester, which is made from a dicarboxylic acid and a diol now. So we said a dicarboxylic acid. We know what a dicarboxylic acid is from the previous one. Now this time we have something new. We have a diol. Now a diol is basically an alcohol with an OH on both sides. Okay, so basically like a di-alcohol, if I were to say it. So let's let's say I have my carboxylic acid here. I'll shade this one again. So I have COOH. I have COOH. Now I have my diol here. My diol, okay, let me just add these. So the boxes can be anyhow. That's what I want to show you from this. So the diol will be OH because you know that alcohols have OH, whereas carboxylic acid have COOH at the ending, right? So now, since we know that a water molecule will be formed, let me change the color. Okay, let's go with it. Since we know that a water molecule will be formed, the H from here will be taken and the OH from here will be taken. So H plus OH, let me write it like this, which will form water. Now this is a small molecule we talked about before as well. So small molecule that is formed, right? So how will I combine them? So I have, let me get back my red blue. So I have my dicarboxylic acid, my CO, and now because there's only one O, I'll do it like this. Okay, let me change the color. O, okay, O. Then, because it's a monomer and I want to repeat it, I'll draw it again like this, and then I'll leave it just a second. I'll leave it like this, and okay, so let me continue here as well. Just once. Just a second, let me move here. Now just cover it like this. Okay, so this is so as we see that this is the linkage between both of them, right? So this is called the ester linkage. Ester linkage. Ester linkage is what? COOO. This is why this is called a polyester, right? Then let's go to plastics and their disposal. So these are the two types that we need to know. This is, yep. So let me just move here quickly. And yeah. So plastics and their disposal. I won't really write this one down because this is just me talking about it. So plastics are also made from polymers. They are chemically unreactive and non-biodegradable, which is why they have environmental issues. Now, when they are burnt, they release a greenhouse gas, which is carbon dioxide, and also releases toxic fumes. Now, since they are non-biodegradable, they take up the space in landfills and fill up very quickly, and they also accumulate in oceans, disrupting marine life. That was about plastics. Yeah, covered it pretty quickly. Then let's go to PET, repolymerization. See. Shit. Now, we have conditions needed to break them. So, this is basically you converting back to a monomer. So, converting PET back to monomer. Now, in order to do this, there are certain conditions that need to apply. We do this using enzymes or catalysts and mild heating. Okay. So conditions needed to break them down are high temperature and pressure as well. High temperature and pressure. Now let's move on to the last part of this chapter, which is proteins. Now proteins here are actually natural polyamide. Now, polyamide means that they must be having the amide linkage in them. So remember that these are natural, okay? Because they usually ask, well, give an example of a natural polyamide. So it's always going to be proteins. Now, if you have done biology, you know that when amino acids are joined together, then they form proteins, right? So the monomers for proteins will be amino acids, which are joined together by amide link. Now, in proteins, this amide link is actually called a peptide link, okay? So peptide link is nothing but an amide link in proteins. So now, since you know that in proteins are formed by joining of amino acids, right? So we'll have them like, so C, H, A, H. Now R is just a group, okay? So I have C, O, H, O, plus similarly the same thing. So another, so maybe let's make this, and then I'll have an H, a C, H, C, O, OH. And maybe since they're all different amino acids, maybe I'll make this one like this. So now the peptide linkage will be over here, the COO and NH, and then this one will form the water, which is the small molecule. So now if I were to draw this one, it would be something like this. So I have it like this, CNH. Okay. Then I'll maybe change it to just leaving it as nothing. So I'll have CONH. Then maybe I could have another one with triangles and then maybe with a different pattern. This will be CONH. I could have another one which could be, let's say, which could have straight lines, and then the same thing would continue. Now you notice over here that this box is different, this box is different, this box is different, and this box is different. Now this is because proteins are formed by the linking of amino acids, and there are 20 different types of amino acids that we can join in any possible way so that we can form a protein. So that's why I could have different amino acids, or in fact even the same amino acids to form the protein. So from over here, okay, yeah, so yeah, that's all there is to learn about polymers. Yeah, if you like this video, make sure to share, like, comment, and subscribe, and I'll see you in the next video. I actually have an exam tomorrow, so I was just